Hey, good morning. Can everyone hear me all right? Excellent. How's the start to Cisco Live? Did anyone get in yesterday and catch some of the sessions? Awesome, awesome. Well, we're here to talk about the most engaging topic of the week, which is firewall decryption. So, show of hands, who has done firewall inline decryption before? Of those of you raising your hands, how many of you love doing decryption? Interesting, I'm the only one. All right, well, first things first, let's get a couple things out of the way, and hopefully we'll teach you some things that might make you want to reapproach it or enjoy it a little bit more going forward. First things first, Cisco WebEx app. Hopefully you all have that already. If you have not yet, please join the discussion. I do think a bunch of you are already in there, but what's cool is I will be monitoring that space for the next month, and frankly, I normally forget to leave spaces, so I'll probably be passively monitoring it until the end of my career at Cisco. So feel free to ask any questions if they come up after today. I'll hang out up here a little bit after the talk as well. So I don't know why this says Agenda 1. I'm just noticing some typos now, but we're going to go through, I guess this is our first and only agenda, a history lesson of decryption, why it is important. We'll talk about some of the challenges. I think those of you who have raised your hands probably are aware of some of those, but we'll kind of do a recap on that. And then we'll talk about a new approach that we developed in Firewall Code 10.0, so FMC FTD 10.0, that rethinks some of the approaches to decryption policy to make it a little bit simpler and more approachable. So first off, let's talk about a history lesson. So we see up here kind of what a firewall was originally built to do, right? This goes back even to the 90s, which was the need to restrict or control access. And we base that on essentially the IP port and protocol, and optionally things like the interface or zone. Pretty straightforward, but as you saw rises in attacks and abuse of things like the application types, and attacks, for instance, hitting your website that is open on port 80, you need to be able to differentiate between what is good and what is bad. So we and a bunch of other vendors introduced a whole bunch of smarter things that we can do, advanced features. So things like seeding block lists into the firewalls of known bad IPs, things like attaching user identity via a variety of mechanisms. We introduced App ID, which we have one of the godfathers of App ID here in the room with us today. Domain and URL enforcement, and then some advanced detections for malicious files, for different types of attacks, things like that. And we and others, the industry at large, calls that a next-gen firewall. So all while this is happening, we had an exponential rise in encryption. So I need to go update this for 2026, but the point is made where you have, in reality, in a lot of networks, nearly 100% encrypted traffic when you're talking about web protocols. Of course, some of the mixture is going to be internal stuff. There's still the odd port 80 server running in the network, or SMB2, that's plain text. But for the most part, all the traffic is encrypted. And not only is the traffic encrypted, but the malicious traffic is as well. And it's trailing a little bit. The attackers will always do whatever's easiest, but as they saw that everything client side is requiring encryption, they obviously jumped on and are doing that as well. So the question is, if the attackers are using encryption, how in the heck do we detect what they're doing, or if an attack is an attack? Let's look a little bit at how a typical web connection works first. So this is an old school, just HTTP, application. You're going to have your three-way TCP handshake, and then you're off to the races. You see the GET request, you see the full URI in that GET request, and you see the file or whatever resource coming back in response. Then along came TLS, SSL, and you have a sequence that looks more like this. And you'll notice the client server completes, and then all the GET request stuff is now invisible to the firewall. It's all encrypted. And you have some things at the beginning that happen, right? You have a client hello packet that exists now, where the client will indicate what it's trying to reach out to. That can be spoofed, by the way, but it is part of the standard handshake. The server says hi, they negotiate on the the parameters, the server provides that certificate, and the encryption starts. And actually on our firewall, you'll see once the encryption starts, Snort kind of backs off because it's like, well, I can't look at anything further. It's all a jumbled mess of ones and zeros now. But there are still some hints in here that are useful, right? Such as the domain name. TLS 1.3 kind of inches that back a little further. The encryption starts more quickly, and so you lose that server certificate visibility. You still have a few hints. And then we have quick, which kind of rearranges some things, and then we have the rise of encrypted client hellos, which in the last few months I'm starting to see a lot more of now that Cloudflare defaults to that if you use them as your service provider or proxy. And with encrypted client hello, you're seeing almost nothing, right? You're just seeing kind of ports and IPs like we were seeing back in the 90s once again. So isn't that interesting? All the stuff that you need to look at to do your advanced inspection is hidden away, right? So let's go back to our history lesson. We have a firewall, and we have a next-gen firewall. But application visibility and control, domain and URL enforcement, and alongside that, intrusion detection and malware protection are all out the window. So is our next-gen firewall just a firewall at this point, right? Are we back to running an ASA with a fancy graphical interface? If all those features are there, or PICs. So how do we regain visibility if that's the reality for us? And with Cisco firewalls, we have a couple of mechanisms that we've been investing heavily in. The first, I'll take a quick detour before we get into decryption and talk about the encrypted visibility engine. Is anyone aware of what the encrypted visibility engine is? Is anyone running that in their environment? Does anyone want to give me a synopsis for a snorty of what encrypted visibility engine is? Anyone?
Traffic analysis encrypted.
Yep, that.
Actually, it gets an assessment and connection secure or not even without.
Yep, good job. It's yep. So traffic analysis without decrypting. We're taking some initial looks at the traffic and making a determination of if it's safe or secure or not, or what the risk profile is. So to dive in a little bit deeper, the encrypted visibility engine is built on big data, which is something that Cisco, among not very many vendors on the planet or entities, can do. So we have Talos, our industry-leading threat intelligence division that is feeding threat intel into our data set. We are gathering data from over 150,000 endpoints per day, both Cisco endpoints like this very laptop I'm presenting on, as well as a number of customers that have agreed to share certain telemetry with us. We're also analyzing, in addition to that, over 2 billion unique TLS fingerprints per day, so not total, but unique different fingerprints, and over 10,000 malicious file samples, unique samples that are new each day, detonated in our sandboxes, either because customers like yourselves have, your systems are uploading files for dynamic analysis. Talos uses the sandbox as well, and there's customers that can do direct uploads. All of that is kind of crunched by some of our data scientists, and we have a feed that goes over using the vulnerability database. This is a feed that we've had for a long time. Our app IDs come through that. Some of our vulnerability fingerprinting comes through that as well. And then we have an actual inline AI classification engine. It is I believe it's a naive Bayesian classifier that runs on the box, takes the outputs from our data crunching, and then it applies those insights to each flow that comes in. And right now we inspect quick and HTTPS traffic in 10.1, which is that out now or coming out very, very soon. We'll also support stun and SSH traffic, same types of techniques. And our engine will assign a risk and process identification to it. If we detect that it has a high threat score, which is the terminology we use, you can set your firewall up so that we'll drop that flow and assign an alert so that you can go investigate whatever endpoint has this malicious process running on it. And if we don't detect a malicious process, we still tag the metadata on it and we let the flow through. So the encrypted visibility engine is interesting and it's very valuable because it allows us to detect things like command and control traffic, things where the process itself is malicious on the endpoint. And that's great, because we don't have to decrypt for that to work. And by the way, if you are decrypting, and this flow is being decrypted anyway, this is still an additive layer of inspection that we're doing on that flow. If we're talking about things like C2, you might be thinking to yourselves, well, that's not going to catch everything. That's not going to catch an SMB file transfer where the file is the bad thing, not the initiating process, or that's not going to detect a web attack against my public-facing web server, right? It's because that's not an infected host in my network. So to get the full range of capabilities, we really need to do decryption, at least selectively, right? Decrypt the things that are suspicious on our network. If we want to detect not a malicious process running, but malware being uploaded or downloaded. If we want to detect other types of post-exploit activity over different protocols that might use TLS, but are not the things that encrypted visibility engine looks at, and things like web app attacks as well. The problem, unlike encrypted visibility engine, which is literally a checkbox to turn it on, and it has like about 1 to 2% CPU impact, it's very low risk, very low impact. Decryption is complex, it's not a checkbox. In fact, I had a customer back when I was working in the field as an SE that told me their bad experience with decryption, and they said, well, we went in and we built a decryption policy, and we set the default action to decrypt resign, and we turned it on. Anyone want to guess what happened to that network that morning? Any show of hands? Yeah, all kinds of stuff, right? Let me see if I can reach that far. Oh, close. So, yeah, effectively their network went down, right? You had a mixture of stuff. You had HTTP errors. This was a college, by the way. So you had students who don't have the cert installed that are having cert errors. Therefore, everything's blocked or broken. You have web apps that are broken. You have even for people that have the cert installed, you're going to have things like cert pinning, all these different conditions that exist. So obviously they turned it off within a few minutes because they started getting tickets from everyone on campus, and they were afraid to approach it again. University is an interesting story because you're probably not going to be able to decrypt the student traffic, but even there's certainly a lot of things that you could decrypt if you take the right approach and make sure you decrypt in a selective manner. But here are some of the challenges. There's kind of 3 tiers of things that I like to divide it by. One is performance. If I scope the box and it's running at 90% and it's doing fine, and I turn decryption on, there's enough overhead and performance that I'm going to exceed the capability of that box most likely, right? And then even if I scope it out right, the price performance equation isn't necessarily a deal breaker, but it is more expensive per compute, like CPU of throughput, of a gigabyte of throughput when you're doing decryption versus not. There's ease of use concerns. So decryption traditionally has its own rule-based policy that for some customers can be dozens of rules long to do different carve-outs and bypasses and things of that nature. And then there's the need to optimize that rule set so that you're doing your decryption in the most computationally efficient manner possible. So not just building the rules, but understanding the order and what the impact of the ordering is. And then there's different things that you have to be aware of to bypass. Like in most jurisdictions around the planet, you shouldn't decrypt banking and healthcare data, for instance, right? And in some countries, it's way more than that. Maybe outbound decryption itself is problematic, and you only want to decrypt stuff going into your own assets, things like that. And then we have connectivity stuff, not even just the complexity of setting stuff up, but we have cert pinning, we have unmanaged devices, we have things like client certificate authentication. So it's a big kind of, a big myriad of things that you have to know about. And when you go and start building a policy, it doesn't educate you on these, right? It assumes that you kind of know what you need to do. So let's look at the first thing, performance. And I can't say that we've made our firewalls free yet, but we have made great strides to improve the decryption performance. So we have in basically all of our new current gen hardware, relative to the tier of box it is, but we have dedicated compute hardware. So on the 3100 and above, we have FPGA hardware, and we have system-on-a-chip gear on the 1200 and below that is designed, among other things, to make decryption much, much more powerful. Flow offload is also another thing that FPGA does. So If we have flows that are deemed trusted by Snort and have a trust action attached to them, we will dynamically offload the remainder of those flows to hardware. So literally, that's less stuff even entering the software stack. So even though that's not directly decryption relevant, it keeps the box a little leaner and able to handle more decryption. And then we have price performance considerations. So NetSec Open is an RFC-based kind of open testing. It's not even an organization. It's a nonprofit consortium that we belong to with Palo and Fortinet and Checkpoint, some other vendors that we've kind of come together to set the RFCs for transparent testing. But using those RFC specs, all the leading firewall vendors have done recent testing. And if you look at the results of the various vendors, we are currently showing about 2.4 times better throughput per dollar spent on our 3100 series versus the similar tier of products from the other firewall vendors, which just means if you need to decrypt, we've made it so you're not spending quite as much money to get the right hardware for that. Now, this is kind of what it feels like, though, traditionally to decrypt, right? You have this, this myriad of different things, this complex system that you have to set up to make it work. And before I joined Cisco, I did decryption, inline decryption at a very large hospital, at a very large insurance company, so I'm well aware it's like a multi-month journey to make it work properly. And this is what an incredibly simple decryption policy might look like almost too simple to actually be usable by any real enterprise, but conceptually, this is the type of thing I might do if I wanted to do inbound decryption to one web server, and then do some basic blocking of kind of old legacy stuff, do some basic bypassing. We have a tag in our app IDs, for instance, of undecryptable apps. I don't know how many people know that, right? It's just a tag in the different tags in the system that you have to be aware of being there. Some different bypasses for different reasons, right? And this is a fairly usable decryption policy at this point, but it's not obvious. You don't click the new decryption policy button, and this rule set just populates for you. So we worked in the 10.0 release very heavily on simplifying the experience of doing decryption. And honestly, a lot of this came from my experience where I used a myriad of different vendors, including Cisco, but also, you got Blue Code and F5, all these different decryption vendors that all decrypt packets just fine, but none of them really, in my opinion, guides you toward what an ideal setup would be for the typical enterprise. So our new simplified decryption policy is notably not rule set based, because I think when most people think of decryption, they don't think of how am I going to build these 30 rules for decryption. They think of what do I want to target for decryption? What exemptions do I want to that? And for different reasons, why do I want to exempt these things? So we have a very simple kind of single screen guided configuration. We have predefined all the common bypasses for you, so you don't have to think of those. If that college went and turned the decryption on, they have to intentionally add the things they want to do decryption for, and they'd have to remove the bypasses if they didn't want the common bypasses to hit. We've also introduced a new framework we'll talk about in a few minutes here on intelligently bypassing low-risk connections, and this is done dynamically on a case-by-case basis right on the box. We've changed some of the certificate handling to highlight things like expiring certs for you, and we've changed the default behavior for inbound certificate handling from a decrypt known key to what we call now a decrypt replace cert. And we'll talk about all this here in a second. But the idea is the final sentence there. We're designing this, or we have designed this, to simplify your configuration process. And we can't promise you we'll avoid every broken connection that might happen on your network, but hopefully you'll leave in a default state with far fewer things to troubleshoot than you once would have had to. So let's kind of walk through the interface. So we'll simulate like that we're scrolling down the screen here. So at the top, we have inbound decryption, which is pretty straightforward. There's not a lot of bypassing you need to do for inbound typically. So what you do here is you have to specify the zones. You have to tell us what direction is that inbound decryption pathway, right? And if you don't specify these zones, they don't default to any, they actually default to none. And the reason we did that is we don't want someone to turn the thing on, attach it, hit deploy, and break stuff because they because we're defaulting to oh, you must want to decrypt everything. So you have to specify your zones, and then you have to add rows with the servers and optionally ports that you want to decrypt on. And another thing is in our old rule-based system, if you wanted to add a new cert, which is a common thing when you're thinking about this new server, this new rule, you'd have to like open a new tab or leave the page, go to our PKI section in objects, attach the cert there, and then go back and what was I doing again? So we've just made it simple here. You can click add new, and I think it'll pop up and show you that, but you can import certs in line. You don't have to leave the page. And then we also start highlighting, again, these are individual kind of end entity certs. We start highlighting with a little warning badge at the 30-day mark that they're going to be expiring and need to be renewed. And then we'll give you a little red badge once they actually expire. Okay, this is expiring in 30 days, I need to renew it. Well, you used to have to go to the PKI page, upload the new replacement cert, go back to your rule set, attach it, deploy policy, and then go back and find the old cert if you want to clean up your objects and actually delete it. And most people just have this ever-growing list of cert graveyards sitting there over time. So we actually made it so you can just click this little pencil, and you can just drop in the new cert into the existing object. So you don't have to swap out objects, go multiple places. Again, trying to make your life a little bit easier, because certificate management's just a reality of the world and the internet today. Yeah? With a new lifetime, you mean the shorter lifetime requirements? So this is a manual workflow. I actually don't remember if I have a slide on this, so I'll mention we did issue new put API commands that you can do as well in 10.0. So this isn't anything to show you in the GUI, but I've written like a Python script myself that leverages Let's Encrypt. So if you're using something like Let's Encrypt or an Acme provider, or really any provider, right? You write your own script or whatever for this. But what the script I wrote, like for my home lab, is it pulls the new cert as a cron job from Let's Encrypt, and then once the new cert is installed on the server that I'm decrypting traffic to, the next command in the Python script is it just sends a put command and uploads the cert into the object in the FMC, and then you could optionally deploy or just wait until you naturally deploy. But so yes, we have added new, the idea of the put commands is that it's a single command now. You're not having to make a new cert programmatically, attach it to the policy programmatically, deploy, delete the old cert like it used to be like a 5 or 6 step thing with a deploy in the middle, and now it's a single command. Yep.
Is that part of 10.1?
This is part of 10.0, so this has been out since last year. Yep. Yeah, so when we were setting to build this, one of my mantras was if you have to build a wizard, that means you've made the feature too complicated. So you could call this a wizard, but this is the whole thing. There is no rule set. This itself is a decryption policy. So to answer the question is there a decryption policy anymore? Is this a wizard overlay that then you're left with a rule set? The old rule set based interface will not go away for a couple reasons, at least for the foreseeable future. One, customers that are using the old rule set and fine with it, we didn't want to yank that away from them, right? There are customers that are fine with it and used to that. There are going to be a few novel, less common scenarios that you might need a full rule set for, where you need to intentionally stack your own rules in your own order for your own reasons. Those are going to be less common, maybe outside of either unique circumstances or very, very large enterprises. What you can do if you want to, and I'm not going to necessarily cover this in these slides, but there is on the decryption policy list screen, there's a way you can actually convert this policy you build into a cloned rule version. It's a one-way street, but then you could continue if you determined, oh, I have this really weird thing I need to do now, and I really need to do this thing I can't do in this view. But we did design this to cover the most common decryption scenarios where I need to define things to decrypt, make bypasses and exceptions for them, et cetera. So yeah. And for that matter, just to be clear, anyone at any point, please raise your hands and ask any questions you have. But yes, in terms of cert management, the hope is that this process of being able to edit in line graphically And by the way, if you go to the object screen, there's an edit pencil on the object there as well. So you can edit it in line in either place, or do the put command to programmatically edit it in line. So let's talk about the new inbound decryption behavior. So since the beginning of our platform, going back to SourceFire days, you had decrypt known key, which is essentially the way that works is you take the certificate, server, and key from the server you're decrypting traffic into, and you put an exact copy of it on the firewall. It works, right? You can even be used as a matching criteria that when I see this cert, I know it's the cert I have, and I will then decrypt. There's some what I would call downsides. The server host names must match. So if I want to make the server a .local inside my network and put a .com on it on the public internet, the only way to really do that is to use a public-facing cert both on the server directly and on the firewall. And you got to put both SANs in the certificate so it'll work on both namespaces. So that's fine. It's a limit if you want to do that. And most people won't. They'll put a .com directly on the server, which may be an exception to their normal naming scheme. Certificate renewals are a big pain point. As you're swapping out the cert on the server because it's about to expire, it's almost impossible to have the server take the new cert in effect at the exact same second that the deployment completes on the firewall. So you're left with a period of minutes, hours, days, weeks, depending on your change management processes, where the certs will not match anymore. And that means for most customers that the decryption will not occur on that server during that time. And depending on how you've built your policy, it could theoretically mean that the connection actually goes out, just depending on how you built your rules. So it just requires more ongoing maintenance, and there's not a lot of flexibility. And some of you have probably already read ahead to the right stanza here, but the way that it works now is the certs, they can match if you want them to still, but they don't have to anymore. We have what's called a replace certificate. So you say, I want to decrypt because it's going to this server in this port. Here's the cert I want you to use, firewall. And the firewall doesn't care what the downstream certificate is. It will use its own. So the certs could mismatch on purpose. I could have like a wildcard cert or a multi-SAN cert on the firewall, and then individual certs on the various servers. When I swap out the certificates, there's not going to be a downtime because as long as the internal server has a valid cert the firewall trusts, and the firewall has its own valid server, they don't have to be the same. So during those change windows, you're not going to have traffic interruption or decryption interruption. So just to kind of illustrate, this is the existing behavior. You have payroll.acme.com. I'm going to take the cert and key from that, put it on the firewall, and boom, now I can decrypt, right? An example of the more flexible design, I might have payroll.acme.local, which I'm not going to expose on the internet, obviously. And maybe I've got some other random servers. I could just make a cert, maybe remote.acme.com. I could put all the SANs on it. I could even do a wildcard, although I'm not a fan of wildcards, but something like this. And that's also going to work now to all of them. So I have one cert now to manage on the firewall. It can expire maybe over a longer window, or it doesn't matter, right? That's the idea. It's more flexible. It fills more scenarios. If you've ever done decryption on like an F5 WAF or something, you're probably used to this, where you're going to have different certs and they don't match, and it just kind of all works. So, great. So we're back to our interface, kind of scrolling down past inbound, and now we're going to look at outbound, which is the more complicated way to do decryption. Let's walk through this screen. Same deal. I have to define the pathway that outbound decryption takes. If I don't define these zones, they default to none. Hence, I will not decrypt. So I have to be intentional on what I'm doing here. I want to define now, or I'll need to define rows of what are the sources. It has to come from this network object range to be decrypted, right? And if you don't put a row in, it defaults to none. So I'm not decrypting anything on accident. Down here, I can go ahead and click Create New, and that'll allow me to upload or generate a new CA, because you have to use an actual certificate, authority certificate, to decrypt. And if I already have my CA, but you know what, I forgot to grab that and put it in my MDM tool, push it out through Jamf or whatever, I can click this download button and just grab it real quick, which is nice. I don't have to go to the object screen to go fetch the CA cert. The idea, again, is we don't want you to have to leave this screen when you're setting things up. We do alert for certificate expiration on the CA. But a lot of times CAs are valid for 5 years, 10 years. It's more common to have a long lifespan. So we're going to give you a 6-month warning on those because you've probably forgotten that it needs to be renewed by the time it's about to expire. All right, and then for outbound decryption, if you scroll down to the next kind of section, you're going to have some bypass stuff. This is what I call basic bypasses. So we often will need to bypass by source or destination IP address, right? And so we can define those. I can add a source or destination. I can also do a bypass by a user. I think that's probably less common, but maybe you have a service account or something that you need to do bypassing for. Same kind of idea. I can add new objects if I need to right here in line. I will mention we will soon have support as well for FQDN in here. I can't remember if that's 10.1 or 10.5, but that's coming very soon. So you'll be able to do FQDN-based bypassing. And then we go down to the bottom section. We have the more advanced bypass reasons. These are normally like kind of layer 7 relevant. So the first thing that I think is huge, and this is where we have been able to do this for a while, but you had to know that there was a tag of undecryptable, an app ID, and target it. We've just made this a checkbox, bypass decryption of known undecryptable applications. And it's checked by default, right? Most people want to bypass the business relevant apps that use cert pinning, like you just want to. So, but if you have a reason, like, hey, we don't actually support or approve Dropbox here, so I'm not going to bypass decryption. If someone happens to use Dropbox.com, we'll decrypt the file download, and if it's the app and it's cert pinned, it'll break, and that, oh well, we don't allow it, right? So we give easy flexibility, and what's cool, you just click this drop down, you deselect the checkboxes of any apps that you disagree with us on and you do want to decrypt. And since the overall feature is enabled, you'll still get net new apps added to the list automatically for you. You don't have to remember to go in and add anything. And we'll also give you this little modified indicator so you're just aware at a glance that you have made changes to the default state of our list. I don't know the contents of the list currently. It has grown since I took this screenshot. I may have recycled this screenshot from Cisco Live last year. But it's somewhere, I think, between 50 and 100 apps, somewhere in that neighborhood right now. If it's an SSL VPN, I don't think we've added any personal VPNs to the bypass list. If you're okay with those apps, yeah, we have a bunch of app IDs for things like NordVPN. If you want to bypass them, you would have to add a default one in. I think for a lot of enterprises, they would appreciate the default being that maybe it breaks rather than gets through. But that's up, obviously up to each of your organizations to determine if you're going to bypass decrypt for personal VPNs. I don't. Yeah, we have a whole bunch of app profiles, like app IDs for things like Claude and OpenAI. I mean, was there like 800 of them or something that we have profiled? Yeah, you can decrypt them. In fact, in my home, I decrypt only my own computer at my house because I don't want my wife and kids yelling at me every day that I'm breaking everything. But I do decrypt like Claude and ChatGPT on my own personal computer. If I remember right, ChatGPT's dedicated app does not like that at all. Claude's actually has been fine. Yeah, at least on my Mac. I don't know about Windows, but on the Mac. Everything kind of works through the browser, right? If you're just in the browser, there's no concept of cert pinning in Chrome or Safari or whatever. So, but yeah, if you want to do, and you may need to do bypasses for those. So this is where you can manually define applications. So you would just go and click I don't know if this thing has a laser pointer. There you go. Click Add New, right? And you can add a new application over here. And this is where you would just say, I want to add Claude, like I've added, in this case, the Apple push notification and Concur. Or if you go over here, you can add a new filter. So you can say, category generative AI, I want to bypass or whatever. I don't know that I'd recommend a blanket bypass for all Gen AI, but it is possible if you want to. Yeah. About what? Yeah, so that's the next thing that no, you're fine, that we'll draw over to. So yes, you can define by URL category and optionally append a reputation scoring to that as well. So I don't remember what's going to draw next. Yeah, let me kind of get the laser going here. Well, I've lost my laser. There it is. So by default, these three are on here. So finance, online trading, and health and medicine, they're defined by default. Again, if you just turn the thing on and don't maybe know what you're doing or haven't read the manual, like those are things every legal counsel at every company are going to say bypass. So basically universally. Yep. In this view, the URL categories for bypassing is across the board. Is a blanket bypass. Yeah. So we have kind of source and destination bypasses that you can do, but the categories would be global. I threw a fourth example in here, which is not by default, which is streaming audio, and I appended a reputation. So what this essentially means is Talos has to designate the streaming audio URL that I'm going to as having a neutral or above, like favorable, trusted reputation. So if someone's going to some like torrent audio site or something that might have a poor reputation, the decryption still occurs in that case. And obviously, this is just decryption decisions. These are not allow block decisions. You can decrypt something or not and still block it in your regular access control. But yeah, so you can append reputation scoring to any rules that you want. And then you also see a lot of these areas we have an apply recommended settings. What if someone deleted these and I couldn't remember what the defaults are anymore? You can click that and it will, if I remember right, it won't remove any customizations, but it'll apply the recommendations that we have for you back to the list if they're removed. And then we get down to the very bottom section of this new interface. So we have intelligent decryption bypass. And I have a couple slides coming up where I dive into detail, but this is kind of an AI-informed, built on Eve and Talos, dynamic decryption bypassing mechanism. And we'll talk about it in a little more detail, and I think it's in the next slide. And then we have the ability to block connections based on a variety of conditions, including the TLS version. So you could block like old TLS prior to 1.2, for instance, and you can block certain certificate states that you don't want to let through, like expired certs, untrusted certs that are not yet valid, things like that. So this is the intelligent decryption bypass. This is something we rolled out in 7.7, and in 10.0 in this new interface is just a simple switch to turn it on. But the fundamental idea is if Eve or Talos thinks something is high risk and you turn those features on in your firewall, they're blocked already. So decrypting is not effectively going to happen. It's just going to get blocked. But for things that are incredibly low risk, most organizations end up decrypting that. And we've run some analysis in our kind of cloud logging infrastructure, and we found that for an average enterprise, between 30 to 40% of all web connections the process is flagged as very low risk by our encrypted visibility engine analysis, and the website you're going to is actually flagged as trusted by Talos. That's a pretty powerful combination. And the odds that that specific connection is going to have anything worth inspecting at a detailed level is probably, there's pretty low benefit to that in the grand scheme of things. So what our intelligent decryption bypass does if you turn it on is we say if there is a very low risk connection or a very low risk process connecting to a trusted server, do not decrypt that. And we detect that on the fly. So as Talos updates reputation scoring and Eve updates process fingerprinting, those just continue to kind of evolve. And then you really focus your decryption on everything else in the middle, obviously as long as you don't have another bypass rule for it that's already accepting it. Yeah? Mm-hmm.
The Eve has to score high, very high in terms of reliability.
Mm-hmm.
In general, we have seen very little traffic being evaluated as a high or very high.
Mm-hmm.
Very small percentage.
Yep, that's good.
Which means,
Well, yeah, as long as there's not false negatives, you don't want everything being bad. Yeah, so the statement, for anyone that couldn't hear, in a typical network, Eve will only flag a very small percentage of processes or flows as high or very high risk. So does that mean that there will be little impact here? I think that's essentially the question. So for the intelligent decryption bypass to work, the process score must be very low. So if it's high or very high, that will be us blocking it. But the decision to bypass decryption will not happen unless it's a very low score on it. Yeah. And then also going to a site that Talos considers trustworthy. These are just a few examples here to kind of illustrate the point, but if we have something that Eve is flagged as malware.njrat with a high-level threat score, it's going to a favorable reputation, not trusted, but favorable. It'll just get blocked because if you've turned the Eve blocking on in your access control policy. Another example, we have Firefox going to paste bin. They're both kind of in the middle. On scoring, we'll decrypt that. Firefox is now going to connectvpn.facebookgmail.com, the site I visit every morning. Has an untrusted reputation by Talos, so as long as you're using security intelligence, Talos is going to block that connection. And then another example, this is just the easiest one I could come up with, but a Cisco, we designate our own EDR tool, Cisco Secure Endpoint, as very low threat score, and going to its own update server or management service is trusted. That would be an example of something that would get bypassed by that definition. And I was just going to pull up the interface to show everyone real quick. Are there any other questions that have come up? Or? Yeah, so east to west decryption is interesting. The overall setup here would work in terms of things like URL bypassing, stuff like that, and app ID bypassing could still come into play. We still do flag app ID sometimes for east-west stuff, but there's other stuff where like an app ID of Facebook is never going to hit on a truly east-west connection. Now, if it's your server in your data center going through the east-west data center firewall on its way out to the internet through an internet firewall, the data center firewall could still flag that metadata because its eventual path is going to go north-south. Yeah, I mean, there's nothing about this that wouldn't work. It's just some of your bypass criteria and stuff would be a little bit different. You'd probably be focused more heavily on the IP-based bypassing and stuff like that. I would think. Yeah. Yeah. Great. So let's see if my FMC is still signed in. It is. So what you'll find in, oh, you're not seeing the screen at all, are you? Let's mirror the display. All right. And so this is a 10.0 FMC. I'll just say just to be clear that I'm running this on an on-prem FMC, but sometimes there's questions on compatibility. Everything we've talked about today is equally relevant in our Cisco Cloud Control-based FMC SaaS, as well as an on-prem one, right? So, but you would go to create new, and you'll see two options now. So what we're terming decryption policy now is just this new interface I've been showing today. We have the rule-based one if you do ever want to still go in and drop directly into the rule-based engine. Another thing, so someone was asking about API stuff earlier. I'll also mention the new decryption policy is fully accessible via API, and it has the same simple constructs that you use. It's all documented in our API Explorer and our API spec. But we would just give a name to it and click Create. And we're essentially dropped right into a decryption policy. Now again, back to the idea we don't want to break stuff inadvertently. Everything is kind of turned off. Now I could go attach this to an ACP, but it won't have any ill effect, right? Because it's all just shut off. To turn on an element, you just flip the switch. And inbound decryption, again, you'll see no zones, it says. So again, if I decrypt now or push now, it's fine. Like nothing is actually being decrypted. I didn't leave it in a half-broken state and then push it to my devices. But here I can go ahead and say, hey, this is my maybe destination, and my I'll just say public is the source in this case. And then you would just add rows here. to create your cert. You'll even see here's an expired certificate that I can update right in line, just drop in the new cert and key, hit save, and then once I deploy that new one is good to go. But you can just add the elements you want. You can do little nice things like type the filter on your objects. This also searches all the fields, so if you have like 20 servers and you got to scroll through them, you can quickly surface the ones you want. The destination ports are optional, so if you have multiple ports on a server that you want to decrypt stuff into, you can leave that blank, or you could make multiple rules for the server, one for each port. But that's basically all there is to it for doing an inbound. And at this point, I could push this out and have this start decrypting. Now, for you can also, even if you turn these on, you can kind of fold them down to get them out of your way if you're looking at different sections. But for outbound, same deal. You have to specify zones. You have the CA and same idea. This is my old sub-CA at my house that expired last year. Now, for the CAs, you cannot edit those in line. Those are more rare things, though, and you can upload your new one here in line. So you still don't have to leave the page. The only thing you technically would have to do is you would have to go to objects to delete the old sub-CA if it's expired and ready to be trashed. But again, that's maybe for a lot of people once every 5 years or more type deal. Although you can make a CA expire quickly, it's just not super common. Same kind of idea here. You can define what your the IPs or systems are that you want to decrypt traffic to. You can actually add multiple to a single rule, which is kind of nice. So if I wanted to, I don't have to have one rule per object. And you can optionally add users in here. I'm going to just, well, I'll go ahead and add a CA just for now. I can also view the details of the CA in line. I can download the CA in line. It'll download it as an encrypted bundle. I can add my source and destination IPs here for bypassing if I want. Add users for bypassing. And then here's that bypass list, so we can actually look. So there's currently 62 apps in here. For the most part, this is all kind of broadly business relevant stuff, but like at my house, for instance, I only access Gmail through a web browser, so I, like, okay, I'll decrypt Gmail, right? You can uncheck any of these and save that, and you'll get the little modified badge here. But again, as the App ID team adds more and more apps over time that we detect, you'll still get all the new ones, net new ones added in. And then down here, you can go ahead and do your searching for applications or filters to add additional custom apps. So for instance, if I need to do that cut through for Claude, I can add that in, and now I have manually defined that. Over here we have our URL categories. This indicates that these are the recommended ones, but pretty straightforward to add things like, again, streaming audio and video might be a common one. Do I really want to decrypt HBO Max? Like, you can, but that would be probably a waste of compute. So we could go ahead and put those in. If I delete these, it restores the defaults. And I misspoke earlier. I couldn't remember if it restored the whole state or just re-added those, but that restores the state. Decryption bypass. I can turn on blocking of old protocols or ciphers, and I can edit these parameters if I want with the different things that I care about. And then I didn't show this in the walkthrough, but down here, the main thing that you may need to do is if you have a custom CA, like my last name being Spry, I have my, I think you guys all run CAs at your house, right? So I have my Spry family CA for all the random lab servers that I have certs on. Or another example that's not built in, if I want to make sure the umbrella block page is trusted, if the firewall sees it, I might add the umbrella root CA in. That's the only thing that most people need to do down here. If you want to enable quick decryption, that's also an advanced option. That's kind of its own topic to talk through. Quick is a unique protocol, but we do support that. You can change your logging settings as well. Now, just to be clear, the way that logging works with decryption is not its own log type. It is a set of metadata fields or logging fields that are appended to the parent connection event. So if you want to log the decryption fields like the TLS version and the action, the decrypt action, all that, these are checked by default, but you would just you can turn those off if you want, or just people have different desires there. There was a hand. Okay, so yes, the encrypted visibility engine does analysis of the initial client connection for processes, whether or not you decrypt. Yeah, Quick and TLS are what we can decrypt for decryption, but encrypted visibility engine, regardless of whether you do decryption or not, already looks at those. And actually in 10.0, it looks at stun and SSH to fingerprint them. Oh, is that what it is? So it'll hit on the older code as well? Okay. Well, Costas corrected me. The Quick and stun, or not, sorry, stun and SSH are going to come with a V2B update soon. And not to decrypt them. Decrypting SSH is conceptually very different than TLS. If anyone wants SSH decryption, please let your account team know, and we would love to get more details on that. But SSH works very differently. I mean, it encrypts, obviously, but the way it handles trust and all of that is very different than. No, other than things like SSH, like most protocols like IMAP and SMTP and POP and SMBv3, like they all use TLS. And so this will decrypt those. It's not limited to HTTPS, but like at my house, I use Apple Mail, and when I see my iCloud IMAP connection, it decrypts that. Like and it can scan the files that are downloaded as attachments in my email. Yeah. Quick is supported for decryption today. It's just not on by default, so that would be a checkbox there. Since we have a couple minutes, I can mention the main thing with Quick is Chrome intentionally ignores enterprise CA signed sites when it's over Quick. So if it sees you going to Gmail and your Chrome browser on Quick and it's being intercepted by your firewall, it actually falls back to TLS 1.2, I think. Falls back to an older protocol that's TCP based. I don't know why. We've confirmed this with the Chromium dev team, so it's not us hypothesizing, but that's an intentional design. It doesn't hurt anything. It just falls back. So that's why Quick is a little finicky, given the most common browser on the planet handles it differently. Quick decryption is added in 10.0, so it's live today. Yeah. So you're mask as in MASQUE? I believe that is normally seen in apps that use something like a client fingerprinting technique. So decryption, theoretically the raw protocol, yes, but in reality most apps, like I see iOS uses it, they use cert pinning generally for it. So it would actually break when you decrypted it. I know the Cisco Secure Access uses mask for its iOS agent, and we have that in our default bypass list. Yeah. 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 So that's a good question. What license tier do you need to do decryption? So the technical answer with a big asterisk is base. No, you don't need a license for it. Why is there an asterisk? Well, for one, if you want to do URL-based bypassing, you need the URL license, right? That's how you get the categorization detail down. And not needed at all technically, but I would question why you would do decryption is if you don't have the IPS license and or the malware license, there's not a lot of reason to decrypt because you're not doing anything with that decrypted traffic other than recording some metadata. So I would highly encourage you to have at least like a threat license if you want to decrypt as well. The malware license, yeah. So recommend TMC, the full license suite, to use all the things for it, but none of them are technically required. Yep. Cool. So I think we're coming up to the end of the hour. I will hang out here for a little bit while I'm tearing down and happy to chat with anyone. But thank you all for spending your Monday morning with me. I appreciate the time.